Hey Math Notes, this is your boy Preetham back at you with some more math, but today we are not going to solve problems. We're switching gears, and you all are about to meet an identity that I've derived myself. And this is, as you can see, limit as x approaches infinity of 1 plus m over x raised to nx would be equal to e raised to m times n. Of course, many of you might be wondering, hey, this guy's crazy, Preetham's just talking gobble smack, but no, that's not the case. I'm going to prove this, and you're going to love me for making your life easier whenever you see questions like this in competitive math or anything, even your math tests. And as far as I know, this is a big part of the BC Calculus and AB Calculus AP exams, the El Hopital rule to evaluate limits. Anyways, let's get started and write the initial equation with let y equal the limit as x approaches, well, look at that x, can't write it for some reason, look at that, x approaches infinity of 1 plus m over x raised to nx. And now, of course, I cannot really apply the El Hopital as yet. I gave it away earlier, but of course I will need to be taking the natural log of this function first in order to achieve a 0 times 0 at the least. So now in this case, let's just take the natural log of y would be equal to limit as x approaches infinity of nx times the natural log of 1 plus m over x. So now, oh, just sorry about that notification, it just popped out of thin air and I just didn't notice. Anyways, moving on. Now, since I have this set up, I am just supposed to check my infinity values anyways. So I am going to substitute just by a visual substitution, infinity times n is just going to be infinity, and then the natural log of 1 plus 0, that's just 1, that's going to be 0. So I have a 0, e raised to 0, but no, that's not how this is going to work. And now to further evaluate the limit, I will need to go ahead and change it into an indeterminate form. Let's grab a different color. So that natural log of y equals the limit as x approaches infinity of the natural log of 1 plus m over x divided by 1 over nx. So anyways, in the previous step, if it wasn't clear already, I am going to use the El Hopital rule, and of course the exponent nx just becomes a multiple after the natural log, because that is the natural log rule of multiplication. Anyways, now starting off, I'll need to take the derivative. Now differentiating the numerator and the denominator one after the other. So the natural log of y would be equal to the limit as x approaches infinity of, now the derivative of the natural log is just ln u. The derivative is just 1 over u times u prime, where u prime is a derivative of u. In this case, our u is 1 plus m over x. So now I'll need to, going by the formula, I'll need to go 1 plus 1 over m over x, and then I'll take the derivative of u, and the derivative of 1 is, 1 is just a constant, so that's a 0. And now m is a constant, so that comes outside the derivative, and now I have x raised to the negative 1, and applying the power rule, that is negative 1 over x squared, so my numerator just gives me negative m over x squared. And now, differentiating the bottom again, 1 over n is a constant, so it just stays at the same place, and now 1 over x again, x raised to the negative 1, that just gives me a negative 1 over x squared. Now moving on, I will need to clean that fraction up a little by bringing the bottom to the numerator and getting it to multiply and cancel out the x squared and all that good stuff. But then let's stick by it step by step. The natural log of y would be equal to the limit as x approaches infinity of negative m times negative 1 times n over x squared times x squared on top as well, divided by 1 plus m over x. And now as you can see, the x squared cancel out, the negatives cancel out, so I am left with, let's scroll down, needing a lot of room for this problem. Alright, that's fun. Gotta grab my pen again. I keep grabbing pens. Y equals the limit as x approaches infinity of m n over 1 plus m over x. Now in this case, when I substitute infinity for x, I just end up with mn over 1 plus 0, which is just mn. So now moving on, I don't need that. The natural log of y would be equal to mn, and so y, to cancel off the natural log, I am supposed to be taking, grab the wrong pen, I'm supposed to be taking the a function, or the exponential function, that is natural log of y equals mn, as I proved up in the previous step. Now y would be equal to e raised to m times n. And now from equation 1, since I said from equation 1, y would be equal to the limit as x approaches infinity of 1 plus m over x raised to nx. So by that definition, in the direct equality, I would be getting a function. And now that's going to be the proof of my identity as well. X approaches infinity of 1 plus m over x. Oh, look at that m. Look at that x. It's nx would be equal to e raised to m n. So, well, that's about it. And here you've met one of my properties, and this can make your life easier on your AP exams, especially if you're a Calc AB or BC student, or even if you're a college calculus student. This might come in handy whenever you have to go through the long LHOP at all. And, well, thanks for watching.